Morning, student. In this lecture, we are going to discuss about latches and data. First, we'll see the latch. Yes or latch. Yes or latch. Now, we'll see that yes is set, R is reset. So, we are having now in the diagram, we can implement the SR flip-flop using to NOR gate or to NAND gate, right? If you are implementing that with to NOR gate, then we are having now two input set and reset input. Right now, here if you are having now the set is 1, the Q is output is 1. Right? At the same time, the R should be 0. Then we are getting now this is it. Now this is a stable state. So that is if you are applying 1 here, then this is the feedback 1, 1 at 1. So you that is we are getting now that result is 1. This is inverted, we are getting now 0. Now this 0 is applied 0 0 and it will make 0 0, it will have the result 0, then inverted, we are getting now 1 as output. So this state, right, 0 here 1 and this is 0, then it will retain 1 and 0 as output, 1 and 0 as output, 1 and 0 as a output, right. Now here after that if you are making that set 0 0 0, there is no change, 0 0 there is no change. See, whatever that one, then that is retained. 0 0. Okay. Next, if it is here, it won't. Next, if you are having that reset is 1 and set is 0, reset is 1, set is 0, that is the input is here. Reset is 1, set is 0, it will make Q as 0, Q bar as 1. Now you see this one, 1 and 1 is getting that 1 inverted, that 0 is retained. Then here 0 0 0 will make 1 inverted, 0 inverted, and you will get now 1. So 1 is retained. So that is if you are S1 and R0, you will get now set. Right? After that, if you are changing as a 0 0, it won't change the previous result. So that result is not changing by if you are giving the input is 0 0. After S1 and S1 is R0, then there is no change in 0, right? Next, if you are making that one as S0 R1, then it will make reset. Reset is Q0 R Q bar is 1. Now this value is retained on 0 0. Then if you are applying 1 1, then this is actually 4-bit state. So here we should not apply 1 1 because the 1 1 is not used, not allowed. So what this is a 4-bit case, right? 1 1, then it will make a 0 0 is not possible, right? So that is Q. This is Q bar. If it is 0, it 1. If it is 1, it is 0. So that is the allowed states. So if you are making this is 1 1, then that is 0 0 is not allowed. So that is case 4-bit case. So only that these are all the valid input. This is the 4-bit input. Similarly, if you are implementing that one with NAND gate, right? So if it is a NAND gate, then the set will make 0 in Q and reset will make 1, right? So in the reverse, right? So that is set to 1 and reset is 0. We are getting now Q is 0, Q bar is 1. Then if you are applying after that 1 1, if you are applying, then 1 1 if you are applying, then that is here it will retain the previous value. Then if you are having S0 R1, then here we are having now that Q is 1, Q bar is 0. Then this value retain for 1 1 as input. 1 1 as suppose taking that our input as 1 1, set 1 and reset 1, then it won't change the state. Then the 0 0 is 4-bit here. Here 1 1 is 4-bit. The NAND gate implementation, the 0 0 is 4-bit. And 00 is 4-bit, not allowed. Right? So that is this actually we are having now the latch is a level one. Why it is level? The one is written, right? So one is the high value. In the duration, it will change the corresponding value. So that is level. We are having now the level trigger. Okay. Then here we are having now this is one. This is zero. So here we are having now that one is one. This is zero at one, right? So if you are applying zero, then it is set. Right? If you are applying 0, 1, it will be applying 1, it is reset. Right? Okay. This SR latch with NAND gate as well as NOR gate. So we can implement that one. Then the logic is inverted. Right? So logic is somewhat inverted. So function table is varying for NOR gate and NAND gate. Then here this SR flip flop, this one is 4-bit. So that flip flop we can make it as by avoiding the 4-bit, then we can have now as a T flip flop. As a T flip flop, we are having now the T flip flop. So before that one, that SR itself, we are having now the control that is with controlled input. Right? So that is the same SR flip-flop with control input, right? So this is SR flip-flop. Then we are having in front of that one, we are having now one enabled signal. So the enabled signal is connected with NAND gate and then allowing that input, right? So if you are applying S1, then this is here enable 1, then it will make a 0. So 0 is set. So S is for set, right? After applying enable only, it will allow the input. So that is we are having enabled signal. So that is control input. Input is allowed, only the enabled signal is high. So enable signal is high, then only it will allow the input. So that is called with control input. SR latch with control input. Right? Latch means we are applying that value 1, then we are enabling that one, then it will make the circuit with the set state. Set state is Q equal to 1. Then it will retain, right? So that is here, it will retain that one. So that is called latch. So it will hold the value 1. So this is called latch. Now if you are applying 0 and enabling, then we are getting now this is a reset. Here it will bring 1. Right. So that here enable is 1 only allowed, right? So enable is 0, then whatever that input, then there is no change. Our input, there is no change. The enable is 1, it will allow, right? So here in this 0, no change in state. Then 0, 1, then it will make reset. Q equal to reset. Then 1, 0, Q equal to 1. Then 0, 1 is indeterminate. So that is 4-bit. So we are not using indeterminate. Right? So that indeterminate means then what the value we can't predict. So that is indeterminate. Now here we are allowing only the 0 or 1 or 0. So for that, the SR flip-flop is going to be designed with allowing that input either 0 or 1. Then that flip-flop is called D flip-flop. D, doggle. T flip-flop, so not doggle. T flip-flop, right? So D. Right? So D is 1, then it will store that value 1. Right? Then D equal to 0 and allowing the enable, then it will make this as 0. So that is as like a data. Right? So that one as here we are allowing the data 0 and it will retain the value 0. If allowing 1 and enabling, then it will retain 1. Then if you are allowing another one and then we are making that another value, it will change. So only we are using now these two input. As in that SR flip-flop, that two input is allowed, right? So this is one is reset, another one is set, right? So that is a D0 then this is reset T1 set, right? So just we are storing 0 or 1. So the one bit we have memory. So that is Q. And D is we are having one. D is a data. So the data is 0, then it will hold that value. Data is 1, it will hold that value. Right? Whenever you are enabling that place. This is deeply covered, right? Then another one, here the forbidden is going to be changed as another flip-flop. We call it as then another one using that. Yes, sir. We can have a master slave flip-flop. What do you mean by that one? As here we are having a data D flip-flop. So if you are having a 0, then the first clock it will make this a 0, right? Then in that clock, so here it will take a data and the negative edge. So we are having the negative lower value, right? So in that higher it will get the data and the lower it will pass, the master will pass the data to D. So it will enable that in the, this is negative logic, right? So that is inverted. Inverted means here, this is a clock, right? So this is in that high, the master is allowed, then low, the slave is receiving the master data. So that one is here, the clock is inverted. So this is enabled. First, master is enabled, then the lower here the negative logic, then this is enabled. So that value is going to be passed through master to slave. This is master slave D flip-flop. Next, we are having now JK flip-flop. Right. Then another flip-flop called JK flip-flop, right? This is a flip-flop. That one is previous one is latch. Now this one is flip-flop using the T latch, right? So here, what we are doing now, then the output Q bar is connected with the J input, and Q is connected with feedback to K input, right? The K is inverted. K is inverted. Then this 2 is connected with R and put it into D of D flip-flop. T input of T flip-flop. Then we are having a clock. So when clock is allowed, then it will get a date. Now the JK, right? So JK is now the characteristics, right? JK, right? So this is the internal. So J input and K input, and then we are having clock, right? So this is actually edge trigger. So positive edge, negative edge trigger. Flip-flop. Flip-flop means here it will have now changing the value. Now see JK is 0, no change. J and K is 0, 0, then it will retain the previous value. That is no change. So the previous value is QT. QT may be 0 or 1, then it will retain in the QT plus 1 also. After applying the clock pulse, it won't change the value. That is, this is the T1, right? So this is one pulse. This is T. Then next, so this one is T1. The next pulse is Q1. This is T1, right? So here in that sequence, we are getting now, this is T, this, T1, right? T and T plus 1. Okay. Now, if you are having that 1 and 0, 1, 0, J1, K0, then this is we are having reset. J1, K equal to 0, this is reset, right? Then the 0, 0, it will need that reset mode, right? So, like here we are having now J0, K1, right? If you are having J equal to 0, then this is we are feedback also here we are having now this is j equal to 0 k equal to 1, right? So suppose you assume that one, this is this 0, right? So that is 0 and k equal to 1, k1 it will make this is 0, right? Then here we are getting that one as already we are having it is 0, so this is 0, then we are getting now 0. Here this is 1 and j is 0, then it will return 0, then d equal to 0, then d is q is retained. Q is retained, then q bar is 1, even though q bar 1, then it won't change the value. So that is the reset state. J equal to 1, then it will go for reset state. And j equal to 1, it will go for k equal to 1, then j equal to 1, it will go for set mode, right? J equal to 1, it will go for jet mode. So this is the set mode, j equal to 1, right? So 1 1 it will make 1, then this one is changing 1, then this is 1, right? Then this is 1, then it will go for 0, right? J equal to 1, then we are having now j equal to 1, j equal to 1, then it will go for set, right? 1 1 and 1, right? So this is here 0 is 1, right? J equal to 1, and then 1 and 1 it will make as here this is 0, this is 1, so this 1 is going to have that 1 as this is making 1, right? Making 1, then it will change that 1 as this is 0, right? This 1 is here we are going to have now as here this is 1, right? So this is 1, 1 is here, this is 0, so it will make it as 0 only. J equal to 1, k equal to 0. So that is in the sets j equal to 1, k equal to 0. And 0 is into, right? And then here we are having now, this is, we are having now that one as 0, 1, 1. So that one is 1. If you are having now, this one is making this as also 1. Then that one is 1, 1. Then this is going to make 1. Then it will make as 1. Right? Then here it will make us 1. This is 0. Right? Then this 1 is going to have that 1 as 1. So 1 is retained. Even though this is 0. Right? Then this is in the set mode. This is in the set mode. So that is here. Right? If you are applying 1, 1, then it will make a complement. It will make a complement. So 1, 1 is not forbidden as like that is. Then if you are having that j and k is 1, so whatever the previous value, previous if it is 0, it is converted into 1. Right? If already 1, then this is converted into 0. Yeah. So that is the complement. So here 0, 0, no change. 0 1 is reset, 1 0 is set, then 1 1 is complement. So this is the JK flip-flop characteristics. JK flip-flop characteristics. Okay, so this is JK flip-flop. Now in the JK flip, using JK flip-flop, we can have toggle flip-flop. So that T flip-flop. So toggle flip-flop, J and K, right? So J is here, J and K is, so toggle flip-flop is always, if you, the current state is going to be inverted. So that is input is J and K is 1. So 1 1, if you are applying clock, then whatever the previous value, the previous is going to be inverted. 0 means it will go for 1 and 1 means it will go for 0. So that is called toggle. So that is T flip-flop. Toggle flip-flop. Toggle flip-flop. So T, how do you design using D flip-flop? D flip-flop, the toggle flip-flop is just we have to connect with the feedback of D, and we are having now this is input. So if you are having this is 1, right? Then here this is already, if you are having 0, then the 0 is going to have that one exclusive or 0 1. Then the exclusive or 0 1, we are getting now the result is 1. So now we are having that value is 1. Then if it is 1, then it will make this as 1, right? This is 1 and this is 1. Then we are getting now that result is 0. So it is diagonalizing the 0. So toggle flip-flop using D flip-flop. So that D flip-flop is we are allowing now a D. Right? So D is as data flip-flop. So whatever that value, then value is going to be retained. So now the T flip-flop is represented by T. So this is the T. T is if you are applying 1, then this is in complement. 1 is going to change the complement, right? So this is the JK flip-flop. So we are having now SR latch, D flip-flop, then JK flip-flop, T flip-flop. Using these 4 flip-flops, we are going to design the sequential circuits. So we are going to study we are going to learn about the sequential circuit by next coming lecture. Before that, we'll see that characteristic equations of that all latch and flip-flop, right? So that is here. This should be in your mind. Then it will be useful for you, right? So that is JK flip-flop, D flip-flop, and T flip-flop, right? So in the JK flip-flop, now you think about that one. So that is here if you are having 0, 0, no change. 0, 0, no change in state. So already QRT is going to be written in QT plus also. Next, if you are having 0, 1, then it will go for reset. So that result is 0, reset. Next, we are having now 1, 0, it will set, then this is set. If you are applying 1, 1, the whatever the previous is inverted. So that is called complement. So JK flip-flop characteristics. Next, D flip-flop character is a data flip-flop. So the C is going to have as a next state. The whatever D value that is going to have as a next state. Whatever the previous it may be, then it will have now that 0 is going to be stored. 1 is going to be stored. So this is called data flip-flop. So that is reset and set. Only the reset and set one is we are taking now. Right? Reset and set is taken now. Reset and set is taken now. These two inputs are combined together as the inverted and something, right? So here T flip-flop is this last, no change and complement. This two is T. This two is going to be implemented as a T flip-flop. Then this two reset and set is going to be implemented in the D flip. So T flip-flop. So T flip-flop is used the mid of these two. Then JK flip-flop is the outside of these two. Right? That is going to happen. So we are having now this is toggle, this is data. Toggle flip-flop and data flip-flop. So like we consider and another one SR latch. Also we are going to SR latches here, no change, reset set, and 4 bitten. The last one is 4 bitten. One is 4 bitten in the SR flip-flop. So we can stop here. We'll continue by next coming